Today we are diving deep into the suburban dream, so let's see how this technology changed everything.
Imagine a substance. Odorless, colorless, non-flammable, and incredibly efficient. A chemical so safe, its inventor famously inhaled it in front of a live audience to prove its purity. This wasn't just a cooling agent, it was a revolution. It unlocked the modern world of refrigeration, air conditioning, and even the hairspray that defined an era. But as the years rolled on, the invisible byproduct of this safe invention began to do something impossible. It began to dissolve the very sky above us. It unleashed an environmental crisis that terrified the world and nearly cooked the planet. This is the story of chlorofluorocarbons, or CFCs, the miracle molecule that became a global catastrophe. To understand why we welcomed CFCs, we must first look at the problem they solved. In the early 20th century, if your refrigerator leaked, it could literally kill you. Systems relied on highly toxic and flammable gases like ammonia and sulfur dioxide. Fatal accidents were tragically common, making domestic refrigeration a terrifying prospect. Enter once again, Thomas Midgley Jr., the dynamic chemical engineer at General Motors. In the late 1920s, tasked with finding a truly safe refrigerant, Midgley and his team synthesized dichlorodifluoromethane. He branded it Freon. It was a masterstroke of engineering, stable, non-corrosive, non-flammable, and crucially, non-toxic to mammals. The importance of this invention was astronomical. It almost single-handedly made domestic refrigeration and air conditioning viable. It transformed lifestyles, enabled mass food storage, and allowed millions to live comfortably in climates once considered uninhabitable. But Freon's greatest strength, its utter chemical stability, would become its fatal flaw. CFCs were designed to last. And they did. Released from spray cans and leaky compressors, these incredibly durable molecules drifted harmlessly through the lower atmosphere for decades. But they were on a long journey. A single CFC molecule can survive for over a century, silently ascending until it reaches the stratosphere. It was in 1974 that two chemists, Molina and Sherwood Rowland, published a revolutionary, terrifying paper in the journal Nature. They theorized that once CFCs reach the upper atmosphere, intense ultraviolet radiation finally breaks them apart, releasing free chlorine atoms. And that's where the real nightmare begins. A single chlorine atom doesn't just destroy one ozone molecule, it acts as a catalyst. It breaks down an O3 molecule, then is released unscathed to attack another, and another and another. Rowland and Molina calculated that a single chlorine atom, introduced by a CFC, could destroy hundreds of thousands of ozone molecules. The environmental impact was now undeniable. In 1985, scientists with the British Antarctic Survey discovered that the protective ozone layer over Antarctica had depleted by a staggering 40% in just a few decades. This was the ozone hole. A shield that had protected life on Earth for millions of years was being aggressively dissolved. The effect on human lives was immediate and measurable. A 1991 review published in the Journal of Photochemistry and Photobiology highlighted that a 1% decrease in stratospheric ozone directly correlates to a 2 to 3% rise in non-melanoma skin cancer cases globally. Increased UV radiation also causes cataracts and suppresses the human immune system. We were being cooked from above. The world finally woke up to the emergency. Just 2 years after the Antarctic discovery, the global community achieved what many thought impossible. The Montreal Protocol was signed in 1987, a universal treaty designed to phase out the production and consumption of all ozone-depleting substances, starting with CFCs. Chlorofluorocarbons were a triumph of engineering utility. They solved critical problems of safety and comfort. Yet, they stand as the 20th century's starkest reminder that short-term innovation, without an understanding of long-term stability, can break the world. The Montreal Protocol proves that global cooperation works, but the scar left by Freon, the killer in the fridge, serves as a timeless warning of the unintended consequences that define the greats of our time. If you found this investigative look into history valuable, do subscribe to the Greats of Our Time for more deep dives into the innovations, people, and choices that shaped our world. Until next time.